Start with a simple but profound idea. Everything around us is made of matter. From the air we breathe to the chair you're sitting on, matter is everywhere. It forms the foundation of our physical world, making up solids, liquids, and gases. This concept is the starting point for understanding chemistry and the universe itself. As we explore further, keep in mind that every object, no matter how big or small, is composed of matter. This sets the stage for our journey into the building blocks of everything. Now let's zoom in a bit. Atoms are the tiny building blocks that make up all matter. Think of them as the basic units, like individual bricks in a giant wall. Atoms combine in countless ways to form molecules and compounds, creating the diversity of substances we see around us. Whether it's water, metal, or plastic, it all starts with atoms coming together. Understanding atoms helps us grasp how matter is constructed and why different materials have unique properties. Atoms join together, they form molecules and compounds. A molecule is a group of atoms bonded together, while a compound is made of different types of atoms. For example, water is a compound made from hydrogen and oxygen atoms. These combinations give rise to the endless variety of materials in our world. The way atoms connect determines the properties of the resulting substance, making chemistry both fascinating and complex. Have you ever noticed that oil doesn't mix with water? That's because substances with similar properties tend to dissolve each other. This is known as dissolves. Like polar substances like water dissolve other polar substances, while nonpolar substances like oil mix with other nonpolars. This principle explains why some things mix easily while others stay separate, and it's a key idea in chemistry and everyday life. Atoms are always seeking stability. They tend to move toward arrangements that are more stable, often by gaining, losing, or sharing electrons. This drive for stability is behind many chemical reactions and explains why certain compounds form. Stable arrangements mean lower energy and greater balance, which is why atoms naturally seek them out. This concept helps us understand why substances react the way they do. Chemical reactions are all around us, from baking bread to rusting iron. During a reaction, atoms rearrange to form new substances. But here's an important rule: mass is always conserved. That means the total amount of matter stays the same before and after the reaction. This principle, known as the law of conservation of mass, is a cornerstone of chemistry and helps us predict the outcomes of reaction. The way atoms are arranged in a substance determines its properties. For example, carbon atoms can form both soft graphite and hard diamond depending on their arrangement. This shows that structure is just as important as composition. By understanding atomic structure, scientists can design new materials with specific characteristics, opening up endless possibilities in technology and industry. Every chemical reaction involves energy changes. Some reactions release energy, like burning wood, while others absorb energy, like photosynthesis in plants. The flow of energy determines whether a reaction will happen and how fast it goes. Understanding these energy changes helps us control reactions, from powering engines to cooking food. Concentration of substances in a reaction can change how quickly it happens. Higher concentration means more particles are available to react, speeding things up. This is why adding more yeast makes bread rise faster, or why strong acids react more vigorously. By adjusting concentration, we can control the rate of chemical reactions in labs and in everyday life. In many reactions, the process doesn't just stop when products form. Instead, forward and reverse reactions continue at balance rates. This state is called dynamic equilibrium. Even though things are still changing at the molecular level, the overall amounts of substances stay constant. Dynamic equilibrium is crucial in biology, industry, and nature, helping systems stay balanced. Chemical changes don't happen randomly. There are always specific reasons behind them, and they follow predictable patterns. For example, adding vinegar to baking soda always produces bubbles of carbon dioxide. By understanding cause and effect, scientists can predict and control chemical reactions, making chemistry a powerful tool for innovation. Matter exists in different states: solid, liquid, and gas. Each state has unique properties like shape and volume. Solids keep their shape, liquids flow, and gases spread out to fill their container. Changes in temperature or pressure can cause matter to shift between these states, such as ice melting into water or water evaporating into steam. Not all matter is pure. Many things around us are mixtures made of two or more substances combined physically, not chemically. Solutions are special mixtures where one substance dissolves in another, like sugar in water. Understanding mixtures and solutions helps us separate substances and create new materials. Matter can change in two main ways: physically or chemically. Physical changes like melting or cutting don't create new substances. Chemical changes like burning or rusting do. Recognizing the difference helps us understand what's happening at the atomic level and how to reverse or control changes. The periodic table organizes all known elements by their properties. It's like a map for chemists, showing patterns and relationships between elements. Each element has a unique symbol and atomic number, helping scientists predict how they'll react and combine. The periodic table is a powerful tool for exploring the building blocks of matter. Atoms connect through chemical bonds holding molecules together. There are different types of bonds, like ionic and covalent, each with unique properties. Bonds determine how substances behave, from the hardness of diamonds to the flexibility of rubber. Understanding bonds helps us explain why materials act the way they do. One of the most important rules in chemistry is the law of conservation of mass. It states that matter cannot be created or destroyed in a chemical reaction. This means the total mass of reactants equals the mass of products. This law helps chemists balance equations and understand the outcomes of reactions. Catalysts are substances that speed up chemical reactions without being used up. They lower the energy needed for a reaction to happen, making processes more efficient. Catalysts are essential in industry and biology, helping everything from making medicines to digesting food. Chemistry isn't just for scientists, it's part of our daily lives. Cooking, cleaning, and even breathing involve chemical reactions. By understanding the basics, we can make better choices, solve problems, and appreciate the world around us in new ways. The study of matter and its changes continues to shape our future. New materials, medicines, and technologies are developed through chemistry. As we learn more, we unlock new possibilities for solving global challenges and improving our lives. We've explored how everything is made of matter, how atoms build our world, and the principles that govern chemical reactions. From the smallest particles to the largest structures, chemistry helps us understand and shape our environment. By appreciating these concepts, we gain a deeper insight into the workings of nature and the potential for discovery.